Welcome to the Infinite Loop Studios standard operating procedure for the ComSwap transform and the ComSwap freeze, respectively. In this quick video, we'll walk through how to use those components in Unreal Engine 5. This tool allows players to freeze or resume transformations on objects around them, and it's fully customizable for your level design needs. So, let's talk a little bit about what each of these components does. Alright? Think of it like this. The player points in a direction, and any objects in front of them, like machines, props, or enemies, can be frozen or swapped between states. It's perfect for puzzles, or atmosphere, or dynamic gameplay moments. There are a couple of good use cases where you would want to swap the state of an enemy, perhaps freeze them, stun them in some way, or swap the state of a level, perhaps have an object that is moving, cease its movement, or have an object that doesn't move all of a sudden start moving. It's very good for creating those liminal spaces that give the player a little bit of control over what happens in the environment around them. Right? Let's break down the three main settings you'll want to work with in order to use these components. The first main setting is the component himself. So, the component itself is actually going to be found under the plus button, and you search com_swap. Anything that has swap within the name is going to be some kind of behavior that you would like to swap on the component, or on the actor. For the sake of this example, we are going to use ComSwapFreeze, which is responsible for swapping the rotation of an object. First off, I have ComSwapFreeze here, and we have the speed that we would like the object to move at a constant rate on each axis over here. If we were to change these values, we would just change the rotation speed and on which axis. The second variable that you would want to look at is actually found on the radio prefab actor component. This is very important. It is not an object within the scene. This is the prefab itself that you would want to change this on. Because the radio is spawned dynamically, you will need to change it directly on the prefab. So the two variables you need to look at are the state swap detection range and the radio cone angle. The state swap detection range is responsible for figuring out the range of any object within this radius is going to be detectable by the state swap. This object is usually going to be around 1,000 for smaller tight spaces, and if you have larger spaces that you would need to swap the states of, you need to make this number larger. This requires some testing on the level design side to figure out where exactly you want this value to sit. It is worth mentioning that the larger this object, or the larger this value becomes, the harder it becomes to process for the computer. This is a micro optimization, and it's not directly important, but it is nice to have a optimized detection range if possible. Alright. Or if you have some level design needs that you don't want objects beyond a certain range to be detected, that is also a capability here. The second one that you would want to look at is the radio cone angle. Now this is the angle that the object is going to be detected in. It actually allows for something like a spotlight effect. If you want to only get objects within a certain cone, that's what this value is for. Now, a value of 0 means a sphere around the player. A value of 0.5 is a semisphere in front of the player, and any value smaller or greater than 0.5 will tighten up that cone. So, if we want something like a flashlight, a value of 0.9 will get a flashlight effect, but a value of 0.5 would mean the whole screen in front of the player. For the sake of representation, I am going to be using a value of 0.9. To change these values, you simply click on the variable, and you change the value under the default value setting. You would also change it under the radio cone angle. Same deal, there is a default value that you would want to change there. Once you have changed the variables, you simply go into the level to test it out, and we click play. Now, you'll notice here that these two objects are rotating at different speeds. My goal is to get into that room. So, it's unreasonable to ask a player to try and jump in here while it's moving at such a high speed. What do? We take out our radio, we press the Q key, and it will stop the object within that range and radius. You'll notice that it didn't stop this object because it wasn't in the detection range. If I press it again, I have now started this object and not this object. This is a really cool use case for doing environments where you have to have some kind of parkour or puzzle solving mechanics. Alright, now I think this gap is a little bit too short for me to get through, so let me start this object again. Right, you'll notice that it doesn't actually start right away. And this is because, this is a very key point, this detection radius must follow the origin. It must be on the origin of the object. So if I want the object to move, I will have to be putting that little detection radius on the origin of the object. For most objects, the origin can be found at the center of the object. This varies depending on the object, and if the artist sets the origin to be in a different spot, that will change it. Alright, so all of that is worth mentioning. That's pretty much it though, in terms of how finicky the system can be. This is up to you guys to figure out how much and what kind of functionality you would like. If you want to avoid that finickiness of having to deal with it being in the origin of the object, you simply have to increase the detection range or radius. Alright, that is it for the comp swap. If you have another behavior that you would like to be a swappable component, the system is made in such a way that we merely need to know what you guys need for level design, whether toggling a enemy behavior or a door spawn or deleting or undeleting an object. Once we know what you need for functionality, you simply let level design or development know, and we can get that done. All right. So thank you for listening. That is the conclusion of the Infinite Loop Studios SOP for the COM swap and COM transform freeze respectively. If you have any further questions, comments, or concerns, please contact myself or Will, and we will be able to develop any extra functionality or answer any questions you might have. For any further documentation, you can find them in the SOP library under the Grimrail Google Docs or under the YouTube videos for the Infinite Loop Studios YouTube account. That will be all for me today, and enjoy the rest of your work session.